Hello everyone, this is Singh 𝐒𝐿𝐲 and I'm back with another discussion video where we'll be deep diving into how you can design an architecture which can handle sudden spikes in traffic. So let's say this is my system, this is my server. If there is a sudden burst of traffic which comes in, how can this system handle it without going down? Okay, so in one of our previous videos we discussed the problem of thundering herd, where if there are unexpected requests that come into the system, it can bring the entire system down when hampering all the users which are accessing the system at that point of time. So today we are discussing how you can handle those sudden spikes in the architecture, in the entire system architecture. We will discuss the use cases, like what are the different scenarios in which these bursts kind of or sudden traffic can happen, and then different resolutions. Okay, what are the resolutions which you can take beforehand, okay, so that you can avoid these kind of scenarios. Okay, so this is one of the thing. Another thing is that let's say these scenarios do occur, then how you can gracefully handle those issues so that not all users are impacted due to that. If let's start with one of the graph. Okay, so this is the graph which I took from one of the hotstar video which is uploaded on YouTube, which talks about how they handle their concurrent traffic and scale to up to 25 million of customers, concurrent users, during a live cricket match. Okay, so if you see here this graph specifically, it was 16.2 million, then it came around 10 million, and from 10 million it spiked to 25 million. So during some live events, okay, let's say some live event is going on, now there is a probability or there is a possibility that something happened in that event. Let's say dhoni Dhoni came into bat. Okay, so there will be sudden burst of traffic that comes in picture, or let's say there is a India versus Pakistan match. So whatever the scenario is, there is a possibility that the traffic goes down and then it can also jump in, and this happens in a very short period of time. Okay, so the idea of the today's discussion or today's video is that if there is a gradual shift in the traffic, okay, there is, okay, so think it in this way. When you make your architecture decisions or like system design decisions to design your system, if there is a gradual increase in traffic versus if there is a spiky increase in the traffic, both the architectures will be little different how you design those systems. Okay, and today is based on how you handle those sudden spikes in your system, burst traffic which can occur. Great. So one example which we discussed here is that this can happen during a live event. Okay, another things could be, let's say a new movie is launched on Netflix or Hotstar. Okay, if a new movie is launched and it is very popular, there's, let's say, a new season of Game of Thrones is launched. Okay, and the first episode is out, so there will be sudden increase in the traffic. Let's say it released at 12 p.m, so a lot of users will logging into the website or through mobile application, and they will try to view this content. Okay, so if there is a new title launch, in any of the streaming websites, and a lot of the users, let's say it's popular across the countries, a lot of the users will come in, and then it can increase the traffic. So skyfit traffic use case, live events we already discussed, it can happen during any match, cricket match or NFL events per se for us, from the US context. Another thing is, let's say some of the traffic or like some of the request failed. Okay, so in those scenarios it can happen that those requests are retried. Okay, when I say retried, assume this kind of scenario. Let's say you have a bunch of microservices in your architecture, M1 talks to M2 and M2 talks to M3. Okay, this is how they talk. Now if the request, or let's say this request from M2 to M3 timed out, this request timed out, so, and it failed with a retriable kind of error. Okay, timeout means this time the request is not able to be served, but if you retry after a certain period of time, it might, there's a high chances that it will be successful. So that's why we retry the request. Now let's say this service retried the request, but since this all timed out, it will also throw the same timeout error here. Okay, and it will throw the same timeout error to the user. Let's say user 1, this user is accessing the microservice 1. Okay, so the same timeout error is propagated. So let's say this service tries retries, okay, and this service also retries, okay, and this user also retries. So if you see the number of retries which keeps, or like there is exponential increase in number of retries, okay. So here it is 3 call, here it will become 3 into 3, here it will become 3 into 3 into 3, okay. So this is how the number of retries will increase. And since all the users are retrying at that same moment of time, the number of retries which come into the system as a whole will be very huge, increasing the traffic, thus creating the situation of spiky workload. Another thing is there is some bug in the client devices. So let's say you have your TV, you have your mobile, these devices connect with our system, okay, this is server. So these devices connect with the system. If there is any bug in these systems, okay, and there are any unexpected calls which are being made to the server, with this can increase the load on this system, okay, thus creating this situation of spiky workloads. So these are some of the scenarios in which the spiky workload can occur. There can be others as well, but yeah, for the context per se, I am hoping that you got these examples, that yeah, in these examples the scenarios of spiky traffic can happen. Now resolutions, let's say uh, we are assuming that in our system, since we are supporting, let's say, live cricket match use case, we are assuming that the scenarios like this can happen, okay. Now how you can prepare beforehand in future, okay, how can you prepare beforehand so that you are sure that this issue, even if it occurs, it will be handled automatically, okay. So let's discuss those resolutions first, how you can prepare yourself, how you can prepare your system beforehand, so that even if these scenarios occur, they are handled automatically without impacting anything. So first thing is pre-scaling, okay, pre-scaling. Now what I mean by pre-scaling is, let's say in general architecture you have one system, one service, which is viewer service, okay. So this service is responsible to deliver all the contents to the user devices. There can be lot of services, but just for example per se, you have like a viewer service, and this viewer service is responsible to deliver the content. Now let's say in ideal time, in general, this service runs 10 servers, okay. This service runs 10 servers. Now in scenarios that there is a live cricket match, okay, there is a live cricket match, India versus Pakistan, there is live cricket match. So you are expecting that increased load, okay. You can assume beforehand that there will be a lot of traffic that will come in at that moment of time, okay. So depending on some historical analysis, okay, let's say these are the users who are interested in this event, or like let's say what were the trends in the past. So let's say it went to 25 million in past, so we will try to scale it for, let's say, 40 million or 50 million, something like that. So what you try to do is you try to do a try to pre-scale your architecture, so instead of 10, let's say you have 20 servers or you have 30 servers. So this is what I mean by pre-scaling. Now the idea here is, you might say that okay, let's scale it for 100 servers, and the scenarios of this system going down in case of sudden traffic will never happen. But we also have to take consideration of cost, okay. It's not like that you have unamounted or indefinite money that you can spend in your cloud provider bills, okay. So you have to keep a balance of minimum cost and customer experiences maintained. Great. So you add a capacity in advance based on predictions. Another thing which you do is you also perform load testing and chaos system to identify if there are any issues in your architecture. Okay, so first thing is that you have the hardware capacity. Now once you have the hardware capacity, you also have to ensure that if this number of users come into your architecture or come hit, let's say this is your load balancer, okay, if the systems of the users hit to this particular load balancer and they are going to these servers, if the sudden burst of traffic this happens, 25 million users, the system will work as expected. Okay, system will work in a fault tolerant way, or like in a reliable way, that even if the traffic increases, the system will work as expected. Now how you can ensure that? You can't wait for that real production traffic to come in. Okay, you can't wait for that real production traffic to come in. What you want to do is, that you do a load testing beforehand. So if you are expecting 30 million customers, okay, 30 million users or 40 million users, you test your system against these 40 million users beforehand. How you can do it? You have to design that load testing framework on your system. Okay, another thing is chaos testing. When I say chaos testing, there is also a video in our system design playlist which you can check out. The idea behind chaos testing is, let's say I have my 100, let's say my 10 servers in place, and if 5 servers go down, let's say there was some hardware issue. You can't have control on the hardware issue, right? So let's say some hardware issue occurred and 5 servers went down. How will your system react to it? Okay, let's say this system is deployed on US East 1. What if this region goes down? How your system will react to it? How your system will react if any component goes down? So this is what I mean by chaos testing. You have to ensure that even like if these kind of scenarios happen, your system is able to recover. So this is how you ensure by a load testing and chaos testing to identify any issues in advance and then fix them. Great. So this you have to do. Another thing is, let's say the scenario happened. So what you can do is, this I think we also cover it here, but the idea here is, let's say this scenario has occurred. So what you can do, you can, let's say this architecture is deployed in multiple AWS regions. Okay, to ensure that region failovers, you ensure that the architecture is deployed in multiple regions and they have active replication. Okay, so what you can do, if some issue occurred in this region, you can also shift the traffic to this region, and for that you have to ensure that there is active replication, so that the migration of traffic from one region to another is smooth enough. Great, let's move to another point is auto scaling. So this is the thing which you can do. Before talking about this resolution, let's understand what auto scaling is. We have talked about auto scaling in a lot of our previous videos, but reiterating on the concept in context of this video, auto scaling means, let's say I have 10 servers at this point of time, and I have configured some scaling configurations that if my CPU is greater than 60, then add one server. So this is plus one server. If CPU goes less than 30%, then remove minus one server. Okay, so these are the, let's say you have configured this auto scaling capacity, and what you do, if there is an increase in traffic, there will be increase in CPU as well. Okay, so this is one of the metric which I discussed. There can be multiple custom metrics which you can use to be defined in the scaling config, but the idea here is, depending on some configuration, you add on one server or remove one server. Okay, but there is actual problem here in auto scaling. We might not be able to use the auto scaling directly. Okay, and auto scaling is much helpful if there is a gradual shift in traffic. Okay, if there is a spiky traffic, because the problem is the server coming up. Okay, a new server 11 is added to the stack. Okay, server is added to the stack, then your application will be deployed, then some health checks will be done. Okay, so there are a lot of things which are done so that it can start expecting receiving the traffic from the load balancer. Now it might take, let's say, 1 minute, 2 minute, 5 minute, depending on the size of your application. Okay, and how you have defined, like what all checks, or like what all downloads which are done at the time of application startup. Depending on that, there is a deployment window. So the server 11 coming up might take, let's say, 5 minutes, but there is a sudden burst in traffic. You can't wait for that 5 minute to handle that traffic. So that's why you have to rely on the scenarios more like pre-scaling, right? Now, another issue which can happen with auto scaling, okay, let's say what you do is, instead of adding one server, you add, let's say, two server. If there is an increase in traffic, instead of adding one server, you add two servers, or let's say five servers. Now the problem which can occur here is the time you need the servers. Okay, there is a sudden increase, okay, from 10 million to 25 million. So let's say you requested AWS for 100 servers, but there is a possibility that AWS returns capacity error, that I don't have this amount of servers at this point of time, but I need at this point of time only. Okay. So these are the things, or these are the errors which can happen with auto scaling. uh, but there are some suggestions instead. Okay, auto scaling, not we discussed that there is a 5 minute time which application startup can take, but you should ensure that your startup time can be reduced somehow. Okay, there are a few of the things which we can suggest. First thing is your application logic. So your application binary should be small enough that it comes up quickly. There are very less dependency, or the code is very simple, that it do not take much time to come up. Another thing is, there are some different daemons which has to be started, some network configurations which has to be made. So all those things should be pre-baked in your AMI instead of running any scripts at runtime. Okay, so there are two scenarios. Okay, one scenario is that you have your AMI created beforehand, which has all the things which are needed pre-baked, or already in place. Okay, so this is your AMI. Another thing is, at runtime, once the application or once the server comes up online, you run some Ansible script. Okay, Ansible playbook, that download this software, download this, perform, run this command, run this command. Okay, so this takes some time, so you are increasing that time. So instead of that, you should create a AMI in AMI's Amazon machine image, as I remember. It's Amazon machine image. Okay, so you can create those in beforehand to ensure that. Another thing is, let's say there are multiple daemons that come in place. Okay, or let's say you download some different dependency, wget, you do wget. So what you can do is, you should try to ensure that these operations can be performed in parallel. Great. Okay, so this we have discussed. One thing we also have to ensure is, there are certain limits which are in place by the cloud provider. So let's say you are making some API calls to the server. Okay, you are making some API calls to the server. Now there is limit on this number of requests which you can make. There is number of limits. Okay, or there are number of resources which you can request. You can't request the infinite number of resources, so you should plan that beforehand. If you are expecting that this is the amount of traffic, or this is the number of servers which I might need, you should talk to the AWS clouding beforehand, so that you have all those details. And this is true for any dependencies which you have. This is true for any of the dependencies which you have. Let's say you have your this Hotstar application. Okay, so before you can watch the movie, or you can watch the live event, you have to sign in or sign up. Okay, and a lot of users, after seeing that, yeah, this is freely available on Hotstar, at the moment when they start watching the match, this is the moment they sign up. Okay, so for signing up, let's say you registered via your mobile number, you enter the mobile number, and then some OTP is returned to your number, and then you enter that OTP. And for sending that OTP, you are depending on some third party provider. Okay, so you have to talk to all this dependency, that I am expecting that lot of users can come into a place, or come online at this point of time, so I need increased capacity. There should not be any throttling which happen. Okay, this is one of the dependency. And the dependencies, you also have to process a payment. Let's say you are charging money. Okay, so let's say you are integrated with the Razorpay. So all these clients have to work synchronously, or you can say together, to ensure that the issues of unavailability do not happen. Let's talk about detection of spiky traffic. Okay, how you can detect the spiky traffic and then take action accordingly. Okay, so let's say I still want to rely on auto scaling. Okay, so we talked about you do some reduction so that the application startup time is reduced. Some other things which you can take into consideration is, instead of relying on, so by default, the graph which are available in CloudWatch in Amazon or AWS are per minute granularity. So uh, you can take action on the 1 minute granularity matrix. So instead of that, you can switch to 1 second or 30 second, so that 1 second, 5 second, 10 second, okay, lower granularity. So ensure that the action is taken quickly and you don't have to wait for 1 minute. So this is one of the thing. Another thing is, this we already discussed, that instead of adding one servers, you can add by 2x or 4x. Okay, uh, uh, one of the metric we mentioned, that along with CPU utilization there can be any custom metric. One important metric which you can use is, what is the amount of processing time which is taken by the device to solve the user request. Okay, if the time is increasing beyond a threshold value, we can assume that even if, let's say, the CPU is normal, since the request time is increasing, we need more connections to handle those requests so that they can be processed quickly. So you should add more servers. Okay, so you have to identify all those custom metrics which you have to add into your system to ensure that your system works accordingly or as expected. Great. So these are some of the resolutions which we can use to avoid these scenarios or pre-plan for these scenarios. Let's discuss for, let's say, what if this scenario happened. Okay, your system is not able to handle the load at that moment of time, or like there is unexpected load which has increased on your system. What you can do so that your user experience is impacted, but it can be somehow minimized. So one thing is, and this we already discussed in our previous videos as well, that you should identify what are the critical components in your architecture. So let's say this is your architecture. Okay, this is C1, this is C2, this is C3, this is C4, and this is C5. Okay, these are the different components which are there in your architecture. Now you have to identify which components are very critical for my architecture to serve the user request. Okay, you have to identify those components. We discussed this same in our thundering herd video. Okay, so let's say this C1 is just used for recommendation. Okay, so even if you are not serving or like not giving recommendations to a user at that moment of time, it is okay. But let's say this C2 is your viewer service. Okay, this is responsible for delivering that, so it is very critical. You can't bring this service down. So you have to identify which are the components you can bring down. And we discussed that there can be capacity errors which can happen, right? So if you're bringing this component down, you have your hardware free for this. When I say hardware free, the hardware is free at that moment of time, so that that hardware can be used as hardware for this component which has lesser hardware. Okay, so this is how you can maximize the use of it. Another thing is, so we mentioned that uh, in the overall architecture you identify what are the critical components. Now we have identified that C2 is very critical component. Okay, and there are a lot of requests which come in. Now the requests which are coming, you have to also identify which of the requests are critical, which of the requests are user request. Some request can be internal request as well. So you have to identify the priority of these requests. If the request is of lower priority, so you can shut them. We discussed the Uber architecture, two of the frameworks, QALM and Cinnamon, in which we discussed how you can drop the request, how you can shut the requests to ensure that your application is working for maximum users. Great. Another thing is, so this is one of the things that you shed lower priority requests. Now again, even after shedding lower priority request, the number of high priority requests are very huge. Okay, if those requests are very huge, you want to do is you want to drop some of the critical requests as well. Okay, so you will drop for some users and you will gracefully handle for those users that right now we are experiencing some kind of issues, you should retry after some time or something like that. Okay, retries again. On the retries part, we discussed one architecture, right? Like m1 m2 m3 talking, and then it can increase the retries. What we want to ensure there is, you should ensure on the retries there is exponential back off with jitter. Now when I say exponential back off, what I mean is that let's say this is your user, okay, u1, and this is coming to c2. Okay, this is your c2 r1 request, u1 user, it is coming to the c2 component, which is viewer service. It is critical component. This is a critical request, high priority request, which is coming to this component. Now what we are saying is, let's say this request timed out. Now if this request has timed out, what we want to do is we want to retry. We assume that okay, this is not this request timeout, let's retry if let's say we will get the response or not. Now if we are retrying, you should retry with exponential back off. What we mean is, let's say you retried at time, you sent a request at time t1, r1 sent at t1. Now the second request will go to t1 plus 2. Okay, the third request will go to t1 plus 4, then it will go for t1 plus 8. Okay, so what I mean by exponential back off is, it is 2 to 1 to 2 to 3, something of that sort. Okay, when I say jitter, you add some sort of delay, okay, in between the request, which is random for the request. Okay, so you want to ensure, if let's say all the requests are being retried, okay, all the requests are being retried and they do the retries and this same interval. Okay, so you'll have a lot of requests as t1, you will have a lot of requests at t1 plus 2, you have a lot of requests at t1 plus 4. Okay, all the requests are going at the same moment of time. So by adding a jitter, you ensure that not all requests will go at same time. Okay, so instead of t1 plus 2, some of requests will go at t1 plus 2, some of the requests will t1 plus 2.1, t1 plus 2.2. Okay, so this is how your jitter helps out. Great. uh, this we already discussed, that you forward the traffic to another region. Okay, we discussed that let's say you have active architecture and you are maintaining multiple regions. Great. Now when I say multiple regions I'm maintaining, there is also a possibility, okay, there is also a possibility that you have sent lot of requests to this region too. So great, you have a lot of users, u1, u2, u3, u4, u100. Okay, and these users were earlier going to region 1. Okay, so you figured out, okay, there is a lot of load at this point of time, so you send some of the users to r2, you redirect those users to r2. Now if these requests are retried to r2, you are increasing the load on r2 as well. You have to ensure that this r2 is not overloaded. So what you do is, we mentioned that every request has priority associated. Okay, so what you do is you reduce the priority. When I'm increasing the priority, it basically means, so lower priority means it's a high priority. So again, take an example, p0 means it's a higher priority, p5 means it's a lower priority. Okay, so to increase the priority to 99, so this r2 will try to solve the request even if it do not if it does not have the capacity to solve this request, it will be shaded off by our load setting framework. So this is all we want to talk about, how we can handle certain spikes in our architecture to ensure that our application is reliable, fault tolerant and available. And to before ending our video, if you haven't subscribed it to the channel MsDeep Singh, consider subscribing. Consider subscribing. You will get to know, or like get to deep dive into a lot of these architectural discussions. We will meet again. Till then, stay safe. Tata. Bye bye.